Hi there. I welcome you to my chemistry channel, The Chemist Chemistry. Are you a chemistry lover? Then you are the right place. This is your home. Don't forget to subscribe and let's move together. I always share my knowledge in chemistry for free on this channel. So if you are a chemistry lover, then you are at the right place. So now, this is a continuation of a topic that we've started already, introduction to atomic properties. So if you haven't watched the 1 and 2, I would like you to check for the link in the description and watch them to enrich your knowledge and understanding about the concepts chemistry. All right, so let's proceed. Ionic size or size matter. Definition: ionic size refers to the size of an ion formed by either gaining or losing electrons. We learn that when an atom loses or gains, in the first place, we learn that an atom can lose an electron and at the same time it can gain an electron. Now, the losing or the gaining of an electron leads to the atom turning into something, and that thing is termed as an ion. So we learned that an ion is a electrically charged particle, and we learned that it is formed when an atom or group of bonded atoms loses one or more electrons. So when an atom loses an electron, it becomes a positively charged particle, termed as a cation. When it gains an electron, it becomes a negatively charged particle or atom, termed as an anion. So when we are talking about ionic size, we are talking about either the size of an anion, that is a negatively charged atom or particle or species, or a cation, a positively charged particle or atom or species. Let's take note of that. So an ion refers to the size, an ionic size refers to the size of ions formed by either gaining or losing electrons. Let's take note of that. So for the ionic size, strength and variation, as I said, we have cations and we have anions. Cation positively charged, anion negatively charged. So now, a cation or cations are smaller than their parent atom. What we mean by that is anytime a given atom loses an electron, its size decreases by default. The moment it releases an electron, its size decreases than before. The reason is this: in a neutral atom, let's say sodium atom as an example. In the sodium atom, a neutral sodium atom, we have 11 protons and 11 electrons. So the total charge there, we have negative 11 and then positive 11. So they nullify each other. So the net charge is 0. But the moment it donates or loses an electron, now it means that one of the negative charge or particles is out. So meaning the number of the positive particles exceeds that of the negative by 1. And at that case, the charge of sodium will become plus or plus 1. Now, if that happened, then it means that the number of protons there exceeds that of the electrons. And in that situation, we've learned also that effective nuclear charge or nuclear attraction increases with increasing number of protons. So in this situation, the size of the atom will decrease. Why? Because nuclear attraction has increased due to the fact that the number of protons there exceeds that of what? The electrons. So the attraction between the center of the atom, which is the nucleus, and that of the valence electrons will be strong, and therefore shrinking or reducing the radius or the size of the atom. Let's take note of that. For anions, it will be larger than its original atom. The reason is because additional negative charge or electron will be added, and as a result, the atom will become a negatively charged. Now, in this situation, the number of electrons will exceed that of what? the protons, which is the positively charged, and thereby decreasing the effective nuclear charge, making the size of the atom more larger than its parent atom. Across a period, ionic size decreases due to an increase in effective nuclear charge. Let's take note of that. Ionic size decreases due to an increase in effective nuclear charge. The explanation is clear. And then down a group, ionic size increase due to the presence of additional energy level. Yes, so let's take note of that. Let's proceed. Sheldon effects. Another name is blocking attraction. It blocks attraction. it blocks nuclear attraction. The Sheldon effect is the reduction in attractive force between the positive nucleus and the valence electron by inner shell electrons. Now, what the Sheldon effect is about, we've learned that the nucleus, which is positively charged, have an attraction with the negatively charged electrons, the valence shell. Is that not it? Yes, but don't forget, when you pick, let's say, sodium, magnesium, or potassium, or any of the transition metal like scandium or chromium, copper, whatever, or any other element on the periodic table, realize that as the shell increases, the inner shells, okay, or the core shells, the inner shells become or serve as a barrier between the nucleus and the valence or the outermost shells, the electrons in those shells. So what we are saying is that the Sheldon effect reduces the attractive force, that is the effective nuclear charge, between the positive nucleus and the valence electrons. And when that happens, it means that the size of the atom will not be reduced. So trends and variation. The Sheldon effect generally increase down a group due to the presence of additional energy levels. We know that down a group more shells are being added. We've learned that in almost, and I said that in almost all the first and the second video lesson. Yes, so more shells are added, and as more shells are added, the more shells are inside the or are between the nucleus and the valence electrons or shell, and in that situation those shells together with the electrons will shield the attraction between the nucleus and the valence electron. It remains relatively constant across a period, so it increases down a group, but across a period it remains relatively constant. Let's take note of that. So this will be the end of this video lesson. If you haven't subscribed to the channel, I will encourage you to do so. Don't forget to like this video lesson and tell me your mind in the comment section. I remain your facilitator, Dozaman. Merry Christmas. Love you.